now time to introduce to our second speaker for the second day of Reinforced 2021 to discuss the Geotechnical Engineering. He has a Master of Science in Civil Engineering major in Geotechnical Engineering in the University of the Philippines, Diliman. He is currently Assistant Professor 1 at the University of the Philippines, Los Baños, teaching Geotechnical Engineering and Foundation Engineering under the Department of Civil Engineering. Currently the Geotechnical Consultant at EA08 GroundTech CE Foundation, Terms Concrete Testing, Sison Engineers Corporation, and RV Parajillo and Associates. He was also a geotechnical engineer for the first 4. He was also an associate design engineer 3 for the Floor Inc. Corporation. Let's all welcome Engineer Andre Cruz. Let us give him a round of applause, everyone.
Good afternoon, everyone. So I can see my. Okay, thank you for that introduction. Before I start, I would like to say good afternoon to everyone, to the students. I hope everyone is safe and everyone is doing well. I would also like to thank Engineer Arlene Paredes for that very wonderful presentation. That was very informative. And I would also like to say thank you to Ronnie for our co-event for always following up. And I would also like to say good afternoon to our UPLB Vice President Dominic Mariano. So he's a very napakasipag na estudyante and a good leader. Yeah. Okay. So I'll just share my screen. Could everyone see my screen?
Yes, sir.
Yes, sir. Okay. So, and before I start, I would like to, nakikita ba na nagsusulat ako?
Yes, sir.
Okay. Thank you very much. Okay. So, I'm here to talk about geotechnical engineering for our Reinforced. So once again, I'm Andre Cruz. Okay, so my presentation will be divided into 2 parts. So for this part 1, I'm gonna talk about a little short introduction about geotechnical engineering. Then for the second one, I'm gonna talk about the geotechnical engineering practice. So basically, I'm just gonna show you what I do. And by showing you what I do, I hope you can have an idea what an geotechnical engineering does. So we're going to talk about geotechnical investigation. We're going to talk about geotechnical analysis for foundation design. So it's divided into 2, shallow foundations and deep foundations. We're going to talk about slope stabilization. We're going to talk about geohazard analysis, and I'm gonna show you a land reclamation project that I was part of, and a tunneling project that I was lucky to be involved in. Okay, so what is geotechnical engineering? So of all my presentations, I usually start by defining three jobs that are often confused about geotechnical engineering. So I'm sorry, that's 2. So that's geology, that's geodetic engineering, and geotechnical engineering. So those 3 are often confused. So most engineers often confuse those 3 works. Okay, so what is geotechnical engineering? So let's start by geology. Okay, so geology is the identification of Earth's physical structure and the processes that act on it. So everything about movement of the Earth, how mountains were formed, about movement, so plate tectonics. So you can ask geologists about that. So a famous geologist right now here in the Philippines is Dr. Renato Saludun. Okay. Okay, so let's proceed. So geodetic engineering. So for example, a project requires a building to be built exactly at this XYZ coordinate. So a geodetic engineer can help us locate that point. So geodetic engineering as a definition is the measurement and the representation of the Earth. So this is a course. So I want to be clear with that. This is a course offered in UP Diliman. So civil engineers cannot be geodetic engineers. So you have to take extra courses. Okay, so yeah. A geodetic engineer can help us locate the exact points of where we want to build the structure and our excavation points. Okay, so I hope I am clear with that. So next, so this is our main topic. So geotechnical engineering. So this is concerned with the analysis and design of foundations, slopes, retaining structures, embankments, tunnels, and other systems that are made of or are supported by soil or rock. Okay, so going back to our project, so we want to build a windmill here. So of course, when we build this foundation will impose loads on our ground surface. So it is the geotechnical engineer's role to analyze and quantify the effects of the loads of this windmill. Okay, so I hope I am clear with that. So I hope I have defined the difference between the three. Next question is how to become a geotechnical engineer. So this is in the Philippines. So usually here in the Philippines, so there are three. So number one is by work experience. So it's either by you work for a geotechnical company. So number two is by taking further graduate studies. So you take your MS, and if you decide you want to pursue a further studies, so you can take PhD. So you can take MS in geotech, then PhD is still in geotechnical engineering. The next step is by taking the PICE specialist exam. So there's a PICE specialist exam for geotech. So for me, I have only accomplished these two. So I have worked for a geotechnical company, and I took my MS. So I graduated last 2014 in UP Diliman. So I still have not taken further studies in my PhD and the PICE specialist exam. Okay, so on this part, we're gonna talk about the geotechnical engineering practice. So the first thing that we want to talk about is geotechnical investigation. So probably, I assume all of you have seen this type of rig in our streets. So because of the many construction projects nowadays, especially in the build, so you can often see rigs like this in the streets or on corners of vacant lots. So what is this rig doing? No? So the objective of this rig is to obtain soil samples below the ground and to have an approximate of the in situ soil strength below the ground. Okay, so how does it proceed? So we proceed by inserting a tube pipe. So usually it's a 2-inch pipe. So we perform wash boring. Then we perform what we call the SPT, hammer test. So that's the standard penetration test. So the objective of the SPT is to get the end value. So the end value is the approximate of the in situ soil strength. So looking at the figure on your right. So this is the tube containing the soil sample. So so by doing this SPT test, we can get a soil sample and we can get the approximate soil strength. So on your left is a borehole log. So this is filled up by an operator. So this project is in UP Los Baños. So I'm sorry, medyo maliit lang, pero this is the end value. So what I want to point out here is the lower the end value, the weaker the soil or the softer. So normally we want a high end value. So this one, so that's this. So what can I conclude here in this borehole lab is that the hard strata is at 4 meters depth. Okay. So this is the formal borehole lab. So as you can see, this project was taken in Taft Avenue, Pasay. So this is around 400 meters away from the LSU. So what can we conclude here? So we have very low end values up to a depth of 4 meters, then our, So the hard strata will start at around 25, that's 4 meters. So that's SPT end value 25. So the role of the geotechnical engineer here is to interpret the results of the borehole data specific to the needs of the project. Okay, so we'll talk about that in detail later. Okay, so next is shallow foundation bearing capacity. So suppose we have this project. So it's a 2-story building, and what does the geotechnical investigation result? So at a depth of to a depth of 10 meters, so the SPT end value is 4 to 6, so that's very low. So we can conclude that that's soft. That's a soft soil or soft clay. So if we go further, 12 to 15 meters, so the SPT end value is around 20 to 25. So we can conclude that's stiff clay, and 15 meters and beyond, so SPT end value of 50. So that's a very dense sand. So for this 2-story building, so it's the role of the geotechnical engineer to recommend what type of foundation is to be constructed based on the information at hand. So, okay, so for this structure, for this 2-story building, so the recommendation is shallow foundation. So the geotechnical's role, the geotech's role is the computation of foundation bearing capacity for this project. So, okay, next. So what if the project is not, so we have the same site, so we have the same soil profile, but our project now is not a 2-story building. It's a 48-story building. Okay, so for the 2-story building, as mentioned a while ago, it is resting on shallow foundations. So how about the 48-story building? So will shallow foundations work? Would anyone from our audience care to answer? Do you think shallow foundations will work? This is a 48-story building, and do you think shallow foundations will work? So it's resting on soft. Anyone can answer? Anyone? What do you think will happen if this 48-story building will be supported on shallow foundations? Anyone? My students from CE 171, would you like to answer?
No, sir.
May bonus, 1 point sa exam. Ayaw? Ay, no? No ang, who's that? Is that Dominique?
Yes, sir.
Yes, so yun, Dominique. Thank you. Okay, so shallow foundations will not work. Okay, why? So the building will be prone to settlements. Okay, so what do we do? So this is the two-story building is on shallow foundations. Then our 48-story buildings will be on, we recommend the geotechnical engineer, looking at the soil profile, will recommend that the 48-story building foundation be on piles. So the piles, the purpose of the piles is to transmit loads to the hard strata. Okay, so let's take a look, quick review on how the methodology of deep foundations of board piles. So number one is we drill. We drill. So then we put, and then after drilling the hole, so we put the rebar cage. Then we pour concrete. So basically we're building a column, but it's underneath the soil. So the geotechnical engineer's role is the computation of pile capacity. So for example, so if we have the soil profile as mentioned earlier, so soft soil, stiff clay, and very dense sand. So taking a look at this graph, this is a graph generated by a geotechnical engineer. So if we want a 15-meter length pile, so let's take a look at the graph. So we want 15-meter length pile at a diameter of 1 meter. Okay, so this is, so we just project. So it's the capacity of the pile is 2,000 kilonewtons. So that's the role of a geotechnical engineer. Okay, so next, so let's talk a little bit about slope stability. So, but before we talk about slope stability, so let's define the factor of safety. So the factor of safety for slope stability is defined as the strength of the soil at the interface. Okay, so this is the interface divided by the weight, the slope mass to induce failure. So normally we want a factor of safety of around 1.5 to 2 to conclude that the slope is safe. Okay, for example, so this is the section elevation of a slope. So the architect likes to build a building here. And the road elevation is here. So, but the existing slope is here. Okay, so what do we need to do? So we need to cut. We need to cut. So we need to cut so that we can build our building here. Okay, so this is our model for the slope stability that I mentioned from the problem earlier. So our building is here. So we have already cut the slope. So we performed a series of slope stability analysis. Okay. Okay, so after performing a slope stability analysis, so this is the result. So this is for the case of strong earthquake. So with the KH value of 0.2 G. So what does it say? So the Fs is equals to 1.279. So we can conclude that the slope is stable and the building can be built. So that's I just showed you one example, but it's a series of slope stability analysis. So it's not that simple. So it's a very complicated and time-consuming process. Okay, so this is the result of the actual site. So we have here our shot tree and the corresponding soil nails. So this equipment is the soil nailing equipment. So the geotechnical engineer's role is to design the slope to ensure that it is stable for all cases, for case where in static condition, for earthquake condition, and for very intense rainfall condition. So in a nutshell, that's what slope stabilization is. Okay, so next that I would like to talk about is geohazard assessment. So this comes side by side with slope stability. So geohazard assessment is the identification, analysis, risk, and its corresponding mitigation construction projects. So okay, so this project was in during the 2017 earthquake in Leyte. So this is a geothermal plant. So this is a geothermal site. So if you look at the picture, that's me. Probably I'm scratching my head. So thinking of a solution to this problem. So this is a pipeline that was damaged by slope failure during the earthquake. Okay, so ayan, so that's also me. So this is also in Leyte. So this is a 20-inch brine pipe damaged by landslides. So looking at the pictures, so you can see that the slope material is granular in nature. So it is a sandy soil. Okay. So next, so this is also a pipeline that was damaged during the earthquake. So it is very near a cliff. So it is just not shown here in this picture, but it's ready to fall off. Oops. So it is very dangerous. So the road has already collapsed. Okay, so this one is the geohazard assessment during Typhoon Osman 2019 in a geothermal site in Bicol. So what happened here, guys? So yun, that's me. So I'm talking to a Carabao. So yun, the Carabao answered erosion and scouring. Okay, so what happened here? So during the normal condition, the water level was here. The water level was here. So during the Typhoon Usman, so the water level was here. So naturally, so that happens is it scarred the foundation. So you can see that the pipe, so the foundation is hanging, so there's no more soil to support it. Okay, so that's what happens here. Okay, so basically, this is a geohazard assessment report. So I just copied, just pasted some important facts. So we write the concern, we write the activity that needs to be done, and what is the recommendation of the geotechnical engineer, and what tests are needed to be done. So the role of the geotechnical engineer in geohazard assessment is to identify the risk involved, what test needs to be done, and number 3 is come up with mitigation plan. Okay, so I hope I have, in a nutshell, you have understood what geohazard assessment is. Okay, so now we're going to talk about a land reclamation project. So this site is the home. We're going to build a power plant, but the only problem is, as you can see, it is swamp. Okay, so how do we build a power plant in a swamp? Okay, so number one is so we take engineered field samples from various quarry sites. So it is the geotechnical engineer's role to assess the quality of these quarry sites. Okay, so these quarry samples. So as you can see, pag yung tao nakatayo on the swamp, so yun, lagpas tuhod. So, but after some mitigations, some engineering mitigations, so number one, we put geotextiles, then we put around 3.3 meter thick gravel, then we place geogrids, then this is what happens. So as you can see, nakakatayo na yung tao. Nakakatayo na yung tao after some engineering modifications. Then, so yun. So after that, can anybody, okay ba yung internet ko?
Yes po, sir.
Nakikita yung PowerPoint.
Opo.
Yes po.
I'm sorry, so the role of the geotechnical engineer is, number one, to specify the engineered field to be used. So what test needs to be done for quality assurance and the design of the reinforcements, just like what we shown earlier. So the geotextiles, geogrids, etc. Okay, so this one is a tunneling project. So the point of the tunneling project is to convey water along this river through this reservoir. So how do we do that? So we build a tunnel, so to convey water from this point to this reservoir. So so this is a section of the tunnel, the aqueduct tunnel. So, and this is the in actual, so this is what it looks like. So in order to build a tunnel, so you need a tunnel boring machine, so like this one. So but this one is around 5 meters diameter. So the one that is used in the Metro Manila mega subway is around, it's much bigger than this one. So this one is for tunnel conveyance only. Okay, so the geotechnical engineer's role is, so the geotechnical deformation analysis of tunnels, coordination with other trades, geologists, structural engineers for a safe tunnel design. Okay, so that will be the end of my presentation.